Hello students. So this is another video where I am solving previous KTU problems. Okay. So this problem is from MOS module 5. This was asked recently, 2020 December. It was asked for 14 marks. The problem reads like this. Rectangular element ABCD of an elastic material is subjected to a shear stress of 17.5 MPa. The planes at right angles carry tensile stress of 70 and compressive stress of 35 MPa. You have to find magnitude of principal stresses, direction of principal stresses, magnitude of maximum shear stress, and the orientation of the plane in which the shear stress is maximum. Okay. So as any problem, the first step that we will be doing in this is drawing the stress block. So if I draw the stress block here, they have given shear stresses 17.5 MPa. So I'll draw the shear stress first. So this direction I will draw first, then equivalent opposite I will draw in this side. This is rotating this element in the counterclockwise direction. So to oppose that, I have a pair of shear stresses like this. Okay. The value of shear stress is nothing but tau xy is given as 17.5 MPa. Then I have a tensile stress of 70 MPa and a compressive stress of 35 MPa in two mutually perpendicular planes. So I have a tensile stress here. The magnitude of tensile stress is given by 70 MPa. I also have a compressive stress here. The magnitude of the compressive stress is given as 35 MPa. So this is my sigma y and this is my sigma x. Okay. So once we have this, I will write down. So we have sigma x as 70 MPa. It is plus because it is tensile. Sigma y will be negative, minus 35 MPa, as it is compressive, and shear will be 17.5 MPa. Okay. How to solve this? This is a direct problem with, you just have to apply the formula. If you remember, the formula for principal stresses 1 and 2 is given as sigma x plus sigma y by 2 plus minus under root sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay. So this portion is generally what is known as the average shear stress, known as sigma average, and this is nothing but the radius of the Mohs circle. So I will calculate these two quantities separately and I will add and subtract them to get the principal stresses. So sigma average is nothing but sigma x plus sigma y by 2. So sigma x is 70, sigma y is minus 35 by 2. So it is 35 by 2 is equal to 17.5 MPa. And radius of the Mohs circle, or the second part of this equation, is nothing but the root of sigma x minus sigma y is 70 plus 35 by 2 square plus shear stress, it is 17.5 square. So this will be equal to 55.34 MPa. Now we can find principal stresses. So sigma 1. Sigma 1 is 17.5 plus 55.34, which comes out to be 72.84. 72.84 MPa. Okay. And sigma 2 is 17.5 minus 55.34, which comes out to be minus 37.84. MPa. Okay, so these are the two principal stresses. So part A is over. So this is part A. Part A is over. Direction of the principal stress. So now we can find the direction of the principal stress very fast. So let's say, so you have to use the formula. tan 2 theta equal to tau xy by sigma x minus sigma y by 2. So this is tau xy, this is sigma x minus sigma y by 2. So this by this without the square. Okay. So this is nothing but tan xy is 17.5 and sigma x minus sigma y by 2 is 130. Sigma x minus sigma y by 2 is 552.5. So this gives 2 theta is equal to, so tan inverse of this will give me 18.34 degree. So tan inverse of this quantity is 18.35. So theta, so this is theta p basically, theta p equal to 9.17 degree. Okay. Okay. So this gives me 2 theta p is the value 18.43, 18.4 degrees. So theta p is 9.2 degrees. So this is one value of one plane. We can get the second plane. So theta p2 by adding a 90 degree to this. So 9.2 plus 90 equal to 92.2 degree. Okay, so these are two planes, 9.2 degree and 92.2 degree. Now, so this is done. So we will first find the orientation of principles maximum shear stress. So that is very easy to find once you have this. If you have this, the orientation of maximum shear stress can be found very easily. So shear stress maximum value plane. So this is given as theta s is equal to theta p plus minus 45 degree. So this can give me two answers. So two values we can get, theta p plus 45 degree, theta p plus 45 degree will give me 9.2 plus 9.2 plus 45, which is same as 45 plus 9.2 will give me 54.2 degree. Another value is 9.2 minus 45, which is approximately 35.8. Okay, so these are the planes for maximum shear stress. Then one last answer which we have already found is maximum. So this is D. This is D. This is B. And the last part is C that we have to find. C will be, C is very easy. We have already found the value of C. So C is for maximum shear stress. The value of this is plus minus R. What is R? R is this quantity. So this is plus minus 55.34 degree. Okay. So sorry, not degree, MPa. MPa. So this is the maximum value of shear. Now, so this is also done. This is also done. So this is what we have to solve. This is the answer for the problem. Now, to improve clarity and to show that you have understood the concept, we can actually draw the stress block. Okay. So what I'll do, I'll just copy this stress block. Now, if you don't draw the stress block also, it is okay, but I would say you should draw the stress block. Now, for maximum normal stress, we have to rotate it by 9.2 degree. So it's a very small rotation that we have to do. So let's take the value. Let's take this stress block. Make a copy of this. I will erase the unnecessary quantities. So shear is not required. So this rotation should be very, very small, approximately or equal to 9.2 degree. So this rotation is 9.2 degree. 9.2 degree. Okay, and these values of this shear, the value of this shear will be this values will be principal stresses. So this will be 72.84 MPa. This is 72.84 MPa. So this is sigma 1, and this will be 37.84. This is sigma 2. Okay, so there is no shear stress. This is the principal planes. So this is one plane. This plane, the angle is 9.2 degree, and this plane's angle will be 92.2 degree. Now, what is 92.2 degree? I have calculated 92.2 degree here. So this plane's angle will be 92.2 degree. This plane will be parallel to this plane. This plane will be parallel to this plane. These two are parallel planes. Okay, so that is the importance of this 92.2 degree. Now, what about the shear? For shear, again we have to rotate it by, where is the angle? 54.2 degree. Okay, so this rotation has given me principal plane, for principal plane. Okay, I can also again rotate this. So this I will rotate by 54 degree. So something around like this, it may look like this. 54.2 degree. Okay, so 54.2 degree is the rotation here. So this rotation is 54.2 degree. So when I rotate by 54.2 degree, I will get a set of stresses. Okay, now the value of shear stress here is it is nothing but it is equal to maximum shear stress. So this plane will have maximum shear stress. The value of maximum shear stress is 55.34 MPa. So shear stress here will be 54.34 MPa. 54.34 MPa. Okay, and the value of normal stress in this plane will be equal to average stress. This value, okay, 17.5. So it is plus. So both will be tensile. .5 MPa. 17.5 MPa. Okay, so this is the plane for maximum shear. So this will give me, this transformation will give me maximum shear stress. So I hope this is clear. So this is this value for your information. This is sigma average. This will be equal to sigma average, and this will be equal to radius of the Mohs circle. Okay, so these two quantities. So first, the moment you consider, calculate these two separately, you are calculating the maximum shear stress, and the normal stresses in that plane, in the plane where the shear stress is maximum. Okay, so this I hope this concept is clear. Okay, so it all depends upon the orientation, how we are considering the stress book. So I hope this answer is clear to you. So in paper, in exam, if you are able to solve up to this, you are expected to get most of the marks or full marks. But if you add this, it will give an idea to the invigilator that you have understood the concept very well. Okay, so I hope it is clear. We will meet in the next video with one another problem. Thank you.